So in our previous tour at the VLA site, we visited the old VLA Correlator. This was built in the late 1970s and early 1980s using the technology of that time. Behind us, we have the old VLBA Correlator, the correlator that has been used until very recently to cross-multiply the signals from the 10 or more separate antennas comprising the array of the VLBA. This correlator was commissioned in 1994 and until very recently took up the tasks of doing the cross-multiplication. It is now shut down and has been replaced with a much smaller device that we're going to go visit next. So that bank of large formatted cards in this big range of racks and another one that's behind it has now been replaced with a small bank of PCs. Not specialized hardware, but instead specialized software. So Walter has been one of the people who has been very tightly connected to this remarkable transformation, and we're going to ask him to explain the how, whys, and wherefores of this software correlator.
Well, like in the evolution from spinning magnetic tapes for data transport to your hard disks, which are commercially available, we're exploiting the mass consumption of electronics by the general public. Instead of using a custom-built correlator, this big device over here, we've been able to put all the logic into a computer program that is able to run simultaneously on many CPUs. These are standard CPUs that we can buy. It's about $40,000 of equipment in this rack. And it replaces and exceeds the capability of this custom machine that was built 15 years before.
How many CPUs are in that?
There are 20 CPUs. Each of those has 4 individual computing cores. So for 80 cores running at 2.5 gigahertz each, we're able to keep up with the current data making rate of the VLBA with a little room to spare.
Okay, and these are Linux systems, I presume?
Absolutely.
Absolutely. And they're easily replaceable. If one of them fails, you just...
Yes, that's one very nice thing here, is not only can we replace any failed units, not that that's happened yet, with existing off-the-shelf units, but we can also upgrade the unit by adding more. These things connect together through standard Ethernet switches, and we can keep on adding more CPUs as our data processing demands increase.
The astute listener is now, I'm sure, asking what to me would be an obvious question. If this little unit here has replaced effectively all of that, why did not the EVLA replace its aging computer about the same size as that with just a few times more CPUs like this? Why not?
Well, this is a question of scale here. The processing job that we're doing for the VLBA is limited in number of antennas, typically to less than 20, and by bandwidth, most importantly, by factors of 8 or 10, resulting in a computational problem that's almost 1,000 times easier. To use software to correlate all the VLA antennas at full data rate would require a huge room, 1,000 of these units, and the power consumption would be quite extraordinary.
Quite extraordinary. So I guess the short answer is we're not quite ready yet to replace the EVLA's requirements for cross-correlation with a bank of PCs, but maybe another 5 or 10 years?
Could be. One interesting thing we found by comparing prices is that if we're able to afford to buy the hard disks to record the data, we can afford the processors and electricity to correlate it.